Lesson 40, Simplifying and Evaluating Expressions Using the Power Property of Exponents. Taking a look at our new concepts here, in previous lessons we've explored the different types of exponent problems that we're going to see in algebra. Let's just quickly review. Anything that is x to the 0 power equals 1. Anything that is x to the first power is x. It's the number itself. We learned what was called the product property of exponents, which you have two exponents that are multiplied by each other if they have the same base. You're actually just going to add the variables that are inside, or the exponents that are in that raised position. So this becomes the same base plus the two exponents that are added together. The opposite is the quotient property of exponents. When two exponents are divided by each other, you're going to take and subtract those exponent values. So it's the same base, and it's the two numerator minus the denominator. And then we learned that you have a negative exponent. It is positive in the opposite location. So if it's negative here in the numerator, it's positive in the denominator. You've got a negative number in the denominator, it's positive in the numerator. Those are all the different properties of exponents that we've learned so far, and today we're going to learn about a new property called power to a power, or the power rule in exponents. In our exploration today, you're raising a power to a power, which means that you're taking what is inside of the parentheses here and you're going to apply the exponent to everything that's inside here. So here's how it's written out. You've got the example of 2 to the 4th power, which is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So you're raising 2 to the 4th power, or 16 to the 3rd power. 16 to the 3rd power means 16 times 16 times 16, but it can also be written just in that power form of 2 to the 4th times 2 to the 4th times 2 to the 4th. See, anytime I'm raising something to a power, I'm taking what I'm raising that power to and multiplying it by itself that many times. So 2 to the 4th to the 3 times is actually like you're taking that power property rule and adding those things together. So I have the same base here, which is 2, and then 4, 4, and 4. 4 plus 4 plus 4 is 12. I wonder if there's a shortcut for that. What's 3 times 4? Oh, 3 times 4 is 12, because repeated addition is the same thing as multiplication. So raising a power to a power actually means if I've got two exponents right next to each other, I take and multiply these things and I keep the same base. So 3 times 4 is 12, so I get 2 to the 12th. For example, in letter A, I've got 3 squared to the 3rd power. I'm going to take the 2 and the 3 that are in the exponent and multiply those together. 3 times 2 is 6. So my answer would be 3 to the 6th power. Now if the question is asking you to solve, then you would actually go and multiply 3 times 3 times 3 times 3 times 3 times 3 to actually find your answer. But here they're asking you to simply simplify, not solve. So you can just write that out in the exponent form. Letter B is 4 to the 5th power, which technically means 4 times 4 times 4 times 4 times 4. Now you're going to do that 2 times, which means 4 times 4 times 4 times 4 times 4 again. Or you can write it in a simple form where you take the same base, 4, and take 5 and 2 and multiply together, which would be 4 to the 10th power. In letter C, you've got 7 to the 2nd power raised to the 4th power. You write 7 as your answer, and then you take 2 and multiply by 4 in the power portion. 2 times 4 is 8, so your answer would be 7 to the 8th power. Are there any patterns, or what conclusions can you draw from these patterns? The conclusion would be that instead of writing it out in this form of repeated addition and then finally doing the product property of 4 plus 4 plus 4, or 5 plus 5, or 2 plus 2 plus 2 plus 2, you just simply multiply those exponents, which is our power rule. The expression, for example, here, a squared to the 3rd power, means to use a squared 3 times as a factor. A squared times a squared times a squared. Well, the shortcut is to just take 2 times 3 and multiply those together. 2 times 3 is 6, which would give you the same answer as if you would do the long way, as writing that out as repeated addition. Now, in letters E, F, G, and H, they ask you to simplify again by practicing this skill. Letter E, a to the 3rd times to the 5th power, you would take 3 times 5, which would give you a to the 15th. For letter F, it's b to the 6th squared. You'd write b to the 6th times b to the 6th, or you could take the shortcut and say 6 times 2 is 12, b to the 12th. Letter G, d to the 4th to the 4th would be d to the 4th times d to the 4th times d to the 4th times d to the 4th times, or the shortcut says 4 times 4 is 16, so it would be d to the 16th. Letter H asks you to use the results from A through G to write a rule for raising a power to a power, and that shows up right here at the top of the next page. The pattern in the exploration leads to the power of power property. If m and n are real numbers, then if it's not 0, then you can multiply those items together. Obviously, if one of these is 0, then it cancels out because anything multiplied by 0 is 0. But if they're both positive numbers, then you're just simply going to multiply those items together. So here you've got 2 to the third squared. 3 times 2 is 2 to the sixth. 8 to the sixth to the third. 6 times 3 is 8 to the 16th. Now the power of power property and the product property of exponents can be used together to formulate the rule of the power of a product. Look at the expression 5x squared to the second to the third. The outer exponent of the 3 means everything inside the parentheses is factored 3 times. So it's like the distributive property but with the power, which you would write that 3 to the 5, that 3 to the x squared. When you write it 3 to the 5, it's 5 to the third power, which is 5 times 5 times 5. And then 3 to the x squared is x squared, x squared, x squared, which is our product property, or our power of a power property, which means 3 times 2 is 6. So 5 to the third and x to the sixth actually equals as it's simplified in this way. The power of a product property means that that exponent applies to both the first term, second term, third term, every term inside of that parenthesis. So here's where it becomes a little bit more complex, but also just as easy because we've learned how to do the distributive property. You're applying that in terms of how we apply our power properties. So here in example 2, letter A, you've got 7a cubed b to the fifth. The 3 on the outside of the parentheses here is applied to the 7. The 3 is applied to a to the third, and the 3 is applied to b to the fifth. 7 to the third power right here is calculated at 343. Then it's a to the third to the third. 3 times 3 is 9. A to the ninth. B to the fifth to the third. 5 times 3 is 15. That's how they get their answer. Does it change when it becomes negative? Not necessarily. Just when you're multiplying negatives, you have to understand that 2 negatives make a positive. So here you've got negative 2y to the fourth. The 3 is applied to the 2, which they show right here. Negative 2 times negative 2 times negative 2 is going to give you negative 8, because it's 3 negatives. And then the 3 and the 4 are multiplied to give you y to the 12th. Now some of these examples can be used to calculate area, because you have powers or exponents, area and volume, which takes you to the second and third dimension, and see how they do that in example 3. Then we have what's called the power of a quotient property. If we have the power of a power property that says if they're next to each other they're multiplied, you probably have the opposite when they are over the top of each other, numerator denominator position, that they're going to be divided. But in this case you've got the power of a quotient property, which means that the power is applied to the numerator and to the denominator. So in this case, m applies to x and m applies to y. It's like it's being distributed to the numerator and the denominator. Here in example 4, you got an example of 2x squared to the fifth. The 2 goes to the 2x squared, which would give you 2 squared and x squared. 2 times 2 is 4. So they get here, and then x squared would be x squared, 4x squared. The 2 also goes to the 5, which is 25. In the letter B example, you see that the 4 is applied to the negative x and the 4 is applied to the x squared. So because there's nothing in front of this, this can be written as a 1, which would give you negative 1 times negative 1 times negative 1 times negative 1. 4 of those negatives is going to make a positive, so x becomes positive, and then 2 times 4 is 8. Here in the denominator, you've got 4 going to the 3, 3 times 3 times 3 times 3, and then 4 going to the y to the third. Those two are power of a power, so you multiply 3 times 4, which will give you y to the 12th. In example 5, it asks you to simplify expressions with powers, in which it's written out in this big complex form. You're going to use the power property to distribute and apply it to everything that's inside this parenthesis, and then everything that's inside this parenthesis, and then you can combine like terms with a product property of exponents, because if it's x raised to a power multiplied by x raised to a power, you just add up those x values. If it's y raised to a power times y raised to a power, you just add up those values. So let's take a look at example 5 here. You've got 4xy squared, 2x cubed y squared. First thing that you're going to do is use your exponent property and apply those exponent rules inside these parentheses. So this squared goes to the 4. 4 times 4 is 16. The x is squared, which will give you x squared, and the y would be 2 times 2, which is y to the fourth, so you get 16x squared y to the fourth. In the second term, you've got 2 times 2, which is 2 squared which equals 4. Here you've got x to the third squared, which is going to give you x to the sixth, and you've got y squared as you're applying those. Next, you're just going to add these up, x to the second and x to the sixth, 2 plus 6 is 8. Y to the fourth, y to the second, 4 plus 2 is 6. And you have your correct answer. Now the only thing that's different about that in example B that you'll see is that there's a negative applied here. Remember, when there's a even number of negatives, it's going to cancel out and become positives. If there's an odd number of negatives, it will remain negative. Your homework assignment for today, after you've watched this video and watched our instructional video, is to go to IXL, click the link for 8th grade skill F.11. It's the power rule, in which you're going to practice applying and answering power rule examples. So here's an example. You've got 7 to the 7th power raised to the 8th power. You're going to raise to a power multiply, which means that you're going to use your power of a power rule and multiply those exponents, which is 7 to the 56th power. Now remember, if it's not asking you to answer or solve, you don't actually have to do that multiplication or type that into your calculator. You're just doing the multiplication of your power. So it just says simplify. So 9 to the 3rd power to the 8th power, you're going to take 3 times 8 and multiply those together. 9 would stay as your base, and what is 3 times 8? 3 times 8 is 8, 16, 24. So I'm going to click this little button. It'll raise up that box, 9 to the 24th, and I've got it correct. Okay? 6 to the 3rd to the 6th, I write 6 in the base. I raise the power and I do power of a power. 3 times 6 is 18, and I've got that correct. All right? You're going to work your way through the different levels of understanding in terms of how we apply our power rule. Again, the base stays the same. Multiply 7 times 4, which is going to give you 28. And you'll show that you've got an understanding of how that power rule applies. It might get a little bigger, it might get a little bit more difficult, but nothing that you can't handle to get up to that overall SMART score between the two power rules that are being applied. Okay? God's blessings with your assignment. Feel free to reach out with any questions.